Thanks, Kamal. So hi, everyone. Again, my name is Paresh Gupta, a technical marketing engineer in Cisco. And what I'm going to do for next probably 10 minutes is provide you a demo of SAN analytics of using the NVMe traffic. Now, NVMe, we have been talking about it, but, even though the devices are out there designed to perform at high level, but the issue is what assurance is there for the devices, right? And when we look at the performance, a lot of times customers ask that, hey, how exactly the write and read operations will work over NVMe, right? So this is how it works. It's very similar to the way it works on SCSI today. The initiator initiates a command. It reaches the target, but what happens in between, the MDS switches make a state of that transaction using our ASICs and the NPU. The target responds back what we call as a transfer ready, and this particularly happened with write operations only. Now, the time taken between the command frame and the transfer ready frame is what we call as data access latency. Well, there are different terms for this particular time across the industry. Probably you have heard of command to first IO, but the overall concept is same. So the initiator receives it and it starts writing all the data back. It sends back a response which carries a status. So the total amount taken to finish the whole IO is what we call as exchange completion time and ECT. Now, the reason I'm showing you this, because this is going to be very important when I show you the demo, because we're not going to write it completely exchange completion time. We're just going to say ECT and DAL. And I'll walk you through a use case where we use the correlation between ECT and DAL to pinpoint where exactly the slowdown is, right? Because when, let's say somebody connects a NVMe capable storage array, they don't get a performance and they are trying to find, hey, where is the slowdown, right? So that's where these metrics will be handy. Now, talking about read operations, very similar to the way it works over SCSI, just that it's one step less. There's no transfer ready involved here. So, as I said, the concept of the metrics continue to be same. There's a concept called data access latency, or DAL, which is the time taken between the command frame and the first response sent by the target. And then ECT is the total time to finish the whole IO transaction. Right. Now, very quickly, even though Kamal went over it, very quickly, just to bring things in perspective, is that when those frames carrying the command frame or transfer readies or response reaches our ASICs on the MDS product line, the ASICs do an inline traffic inspection of the headers, and then some of the selective headers, only the headers, are sent to the NPU. This NPU is a extremely powerful packet processor that resides on board. All right, so the packets or the packet headers are not leaving anywhere else except the data path, right? And just to stress it again, we only send headers to the NPU because of two reasons. Number one, sending everything is not required because most of the metrics that we want to calculate can be calculated from the headers. And number two, sending data anywhere off the data path may be a security risk for a lot of customers out there. Okay, and when NPU receives these headers, it runs a microcode on it, takes those time differences, some of the metrics that I said, and all those metrics are calculated at a flow level. And the way we define a flow is a unique combination of an initiator, a target, and a LUN behind the target. Now that's for SCSI. For NVMe, we call it as initiator, target, and then there's a concept called namespace, which is very similar to LUN, but we call it as ITN flow, right? So that's what you're going to see in the demo. So when the NPU has the metrics, we are not going to solve all the problems of the world on the switches itself. We have to send these metrics out to a centralized receiver. That's what we do using streaming telemetry. And using streaming telemetry, the switches are able to send these metrics to DC and MSAN insights. Or we also have a partnership with Watana, Virtual Wisdom, or it can be any other receiver, which is able to receive these metrics. Now, one point before moving further, I would like to mention that if you look at the overall architecture, because these NPUs are part of every line card.
Sure. I have a question.
Sure.
So you do all the heavy lifting in the switch. So you collect all the data, you organize it, and you send it outside. So, but what I didn't really understand is, do you need solutions like Virtana to get a graphic visualization of what is happening, or alerts and monitoring and everything, or do you also have your own solution that gives a view of what is happening to the customers?
Yeah, so from Cisco, we have SAN Insights as an analytics offering. We also can send it to Virtana Virtual Wisdom, but that's not required. It's just an option.
Okay, very good. Thank you.
Right, and I'm going to show you a demo of DCNM SAN Insights just to make it more clear.
Okay, nice.
Okay, so going back to the point I was saying, if you look at this architecture, because the NPU is part of a module and it's part of a fabric switch also, I mean, the larger the fabric, the more NPUs our customers get. So if you look at that faded picture of 9710, that's an 8-slot director. That means in a single switch, we can have 8 NPUs. And if you're looking at, let's say, 5 switches in a single fabric, we're talking about 40 NPUs distributed throughout the fabric. Now, that's a lot of compute power natively integrated within the fabric to calculate these metrics and send it out. Okay, and one last point, even though I keep on saying—
So just a question. So the NPU, is that something from a metrics perspective that the user can program, or is that just primarily a Cisco managed computational engine? So if I wanted to do some special metrics based off the headers, could I do that, or would I have to ask Cisco to provide that?
So there are already 70 metrics per flow that we provide. Now, if you think there's a metric—
Only 70?
70 per flow, 70, yes, only 70. Now, if you look at the next slide, the last bullet that I say here, every flow we are calculating 70 metrics on a single switch. We support 40,000 flows. And by the way, that's a QA certified limit too, only. In internal Cisco labs, we have seen around 100,000 flows per switch that we can monitor. Now, we're looking at like around millions of metrics at every export. If you think that's not enough, reach out to us. We'll be more than happy to add more metrics, because I'm sure there's a lot of room for improvement.
Okay, thanks.
Sure. So I think the point that I was saying, that even though we support this capability in the 32 gig products only, but guess what? We need a 32 gig capable port at least once in the end-to-end data path. That means we can make it work with older generation switches too, so our customers need not rip and replace. That's a constant complaint that new features are only part of the new products, and customers not going to upgrade overnight, right? So that's one of the key benefits. The other thing is the other product lines too, like Nexus 9000 can work, at host edge. Even Cisco UCS Fabric interconnects can work on host edge. Not just that, this capability work in NPV mode too. E1F, the upstream NPIV parent, is a non-Cisco switch, right? So this is a truly, integrated by design architecture to make the journey of NVMe seamless for our customers. Okay, so those were some high-level points. Let's jump into the demo. Okay, so this is DCNM. I guess you had a question that whether Cisco has its own solution. So for those of you who have been aware of DCNM, it's a long history, but now I think from last 2 to 3 years, we also integrate an analytics engine within DCNM, and that's what we call as SAN Insights. Right? So when you go on dashboards, what we call it SAN Insights. Now, the purpose of this dashboard, and I'm going to walk you through a use case, is to provide you a high-level view, because not every time people like to jump into details. Right? A lot of times management says, hey, every Monday morning, just let me know the performance health of my entire infrastructure. Now, what you see here is like around there are 5,499 ITN flows. So everything that you're seeing here is NVMe traffic, right? Also, you can instantly figure out what is the slowest end device. So this Windows server, which is running some LPE, HBA, is taking longest to finish its read. And if you remember what ECT is, it's the completion time, right? So this Windows server is taking most to finish IOs. right? So this is a high-level screen, and let me walk you through one use case because there's a lot that is possible, but in the interest of time, we cannot do everything. So you can go on host, and what you get here is a sorted list of all the hosts as per the performance with the worst performing host at the very top. And a lot of times, what our customers say that there are two occurrences. Obviously, they're not going to sit here and look at these screens all the time, right? They have better things to do in their lives. So there are two initiation points. One is either somebody complains, and if somebody's complaining, that's okay. That's not really proactive, but yes, those are realities. The other thing is, can we tell them before a user complains? And I think this is what exactly is happening. I think if you look at the screen right now, you get all the hosts on the left, and then you get a topology. These are the two paths that this particular host is using to reach its target ports. And this is a UCS blade server running behind UCS fabric interconnects, the 4th generation fabric interconnects. This is a Red Hat host with 4 paths to the storage. And if you see this dot, this is where we are tapping into the traffic. Okay, if I select the other path, you're going to see this green dot with the black outline moves over. Now, one of the things that catches my attention is that one of the flows is yellow. So let's try to find why this flow is yellow. What's impacting its performance? So I can click there, and this is where I get a third level, where extreme low level of troubleshooting to find the answer that where exactly is the bottleneck. Right now, if there's something yellow here, that tells me that there's something within the storage subsystem which is delaying the whole application performance. But now I want to know what exactly within storage, because it could be host, it could be storage area network, or it could be storage array. So for that, I'm just going to try to figure out what's happening here. So I see some kind of dip here. Let's see what has been happening over the last 12 hours. And okay, so this is great because I see a kind of pattern. And if you try to see the pattern, let me disable the completion time. Let's just focus on IOPS for a second, because if IOPS dips and it stays like this for a second, which is like around 6.6. And if you see, this sounds like around 15 minutes of dip in IOPS. So this 15 minutes for sure looks like the application users are going to complain because the IOPS is dipping. Now, we don't know why IOPS is dipping. We just know IOPS is dipping. And if you want to know why, what we suggest is make a comparison to your completion time and try to figure out where exactly is the bottleneck. And also compare to the data access latency, because completion time is the end-to-end delay, and access latency is what generally induced by the storage arrays.
So in this regard, the ECT for this whole period is pretty flat, except for a couple of dips at the end of this, and the DAL is also pretty flat except for a couple dips. So it doesn't look like it's a SAN issue per se. It doesn't look like it's a storage issue as much as an application issue. Is that the perception?
We haven't really reached to that level, because generally, what we say is that the completion time is more. It's a storage issue. And if the access latency or DAL is more, then it really high confidence that we can say that it's a storage array issue. But you're right, in this graph, we don't see that, right? So it really depends what pattern we catch. And I think on that note, I think I have another very clear example, because, finding that exact pinpointing of the issue is really important. And I think on the other server, when I was looking at, so one of the things that probably catches your attention, that right now you can see that one of the parts is missing, right? A lot of customers complain about that their logins have happened on both the paths, but the traffic is not flowing over both the paths. So this is where they can figure out. And let's say if we go and look at this host, and I can also do custom graphing, which is essentially giving me raw access to the database. Okay, so in this example, you see the IOPS, and then if I do ECT, and if I also plot DAL in the same graph, now you see there's a very clear pattern of whenever IOPS dips, ECT dips too. Sorry, ECT increases. Sorry. I mean, more the ECT, the worse it is. So you see ECT goes up at the same time when the IOPS dip, you see the clear pattern there. And then, by the way, if you want to know why the ECT is more, that's when we compare it to DAL. And you see the DL exactly matches with the spike in ECT. So this particular scenario, I would say, number one, yes, the application is getting slow. If at all it's getting slow, is because of storage. Number two, it's happening because the IOPS is dipping. IOPS is dipping is probably because it's taking more time to finish the IOs. And by the way, the more time is generally spent within the storage array. Right, so that kind of pinpointing that we can do and help our customers to, make their journey smooth with NVMe, because, I mean, even though they are big promises, and I'm not doubting any of those promises, but guess what? In production environments, when our customers deploy, they're not going to get this performance on day one. They're going to be 100 roadblocks. And the question is, what assurance we are going to give them, right? So that's exactly what this product provides.
I have a question. I mean, if you get a complaint about performance, you get a complaint from a user. I mean, the application is slow. I mean, the web browser is not loading the page or whatever. So you never start from the infrastructure point of view to dig. Let's look why this, this server is slow. But actually, you have to start from, from the top and say, okay, there is an application that is slow. Let's check and go down deeper and deeper and deeper in the infrastructure until I found it. So my problem is, how can I use this solution if, I have to have this down to top kind of process of thinking, while most of my users have this problem at the top. You know what I mean? I mean, so it's an application problem to start, and you can guess that you have an application.
I totally see your point. And if you remember, that's what I was saying a few minutes back, that, you need a point to start with. People are not going to sit in front of the screen and follow what I'm trying to do here, right? But the other thing is, you can actually do that. And let's say, I mean, this is a classic example. If you look at this particular environment, the host is doing the read and write traffic. If you look at the throughput, both the read and write commands are working. That means your application is not complaining. So nobody's going to complain about it. There won't be any case raised. But for those of us who manage this environment, we get worried about that, right? So this is where, if we have to take one step proactive without really waiting for somebody to complain, this can be one place to start. Otherwise, the traditional approach that application broke down, it's getting slow, and now I want to find the answer, for sure, yes.
Hey, Paresh, can I ask a question? So are you providing any guidance to the end user? We're doing a lot of digging in here to try and troubleshoot a problem. Is there some intelligence on top of this to guide somebody to say, here's a potential issue, you might want to go and have a look at X, Y, and Z?
Yeah, so I mean, for that, and this is one last question in the interest of time, but we provide this sorted list of green things. You see these green dots? I mean, right now, everything is working really great. That's why you don't see anything turning into orange or red, but that's what we suggest, that follow these things, because you're right, customers don't know how bad is really bad or how good is really good, right? Can I say 200 microsecond of response time is good? I don't know, right? I have to learn from the environment. And that's what this product is doing, which I didn't talk about, but you see, we kind of maintain a baseline for every flow, right? And based on the deviations from the baseline, you see the thresholds at the very top. I mean, these are the topics for a maybe longer session, but that's what we do. And that's how we turn these things into different color codes.
Yeah, but I think it's important that it's learning, and how, because that was one of my other questions about how you're defining the baselines. How do we know when something's gone orange? How much of a deviation is that? And actually, does it matter? So, balancing some analytics and some internal intelligence to maybe help identify that would be really useful.
Yeah, absolutely. I glossed over those facts because they're a bit too detailed for today, but you see these thresholds, you can change them if you want to, and accordingly they'll change the color. And there's a help thing here. It's a question mark. This explains that what is the analytics working in the back end, what is the logic behind that.
Paresh, I got a quick question for you.
Last one.
Based on what I'm seeing, I think it's great information, and the analytics is wonderful. But you made a point saying that if it's all green, the application is not going to be complaining. But in fact, we all know that the application can also have issues. So to Enrique's point, when the problem comes in, it's going to come in from an end user who has an inability to get their application to run whatever results they're looking for. And that's where you're going to be starting, is from the top down. To his point, this is actually going from the bottom up. Are there plans for Cisco to integrate some kind of APM or even clicker that Cisco acquired some years back to get more of that depth and the multi-dimension into the entire infrastructure from hardware to application?
Yeah, so I mean, as part of the architecture, if you remember, I said that these metrics are collected by the switches and sent over in open formats. Anybody can tap into it.